So congratulations on completing the course on discrete data analysis. By now you should be able to recognize that a different set of techniques is required for regression modeling when we have discrete outcomes such as binary responses or counts. You should be able to identify the assumptions made by the linear model which would prove too restrictive in this case, and be able to appreciate that the generalized linear model provides a framework for modeling such data. We had started with a very simple situation of the 2x2 table, and you should be able to name as well as use common association measures like the risk difference, the risk ratio, the odds ratio to measure association in this case, as also to appreciate that the inference made in this case might depend on the level of a third variable which needs to be taken into account, and failure to do so can lead to a situation called Simpson's paradox. You should also be able to identify the various components of the GLM, namely the linear predictor, the very important link function, and the variance function, whereby we note that unlike for a linear model, we now have a situation where the variance and mean can be written as functions. That is, the variance can be written as a function of the mean, and hence they cannot be modeled independently. You should be familiar with the use of the GLM function in R, and you should have studied several applications such as the application to count data for the Gala data set and several others such as the auto insurance data for gamma regression. Gamma regression, note, is also a special case of GLMs which can be used for situations where it is more natural to consider the coefficient of variation as the measure of variability in the data. You should be able to perform inference and appreciate the requirement of the likelihood-based methods. However, after having studied the likelihood, we have seen some situations in the context of over-dispersion and under-dispersion where it is not possible to use likelihood-based methods, and in such situations we have identified quasi-likelihood methods. Finally, we have looked at some extensions of the GLMs, firstly to the case of GLMMs, and you should be able to appreciate the requirement for subject-specific models as well as the utility of subject-specific models for the situation where we have longitudinal data. We have studied an application to growth data. Finally, you would have some small idea about the motivation for GAMs which arise when the dose-response relationship is linear, and we do not want to impose any prior restrictions about the nature of nonlinearity. Last sentence needs to be changed. Finally, you should have an idea about GAMs, or generalized additive models, in which the dose-response relationship is not linear, and we do not want to assume any prior restrictions about the nature of the nonlinearity. The final topic we touched upon in this course was the extension of such models to the case when we have generalized outcomes.